Now, still on dynamics of motion of bodies, we'll come to this aspect of the dynamics of motion, that is looking at the dynamics of vertical motion. I've already drawn my free body diagram, on the body of mass M, and also drawn the coordinate system, my y and x coordinate system. And here, the motion of the body is only in the vertical plane. And here, we can see two forces acting on this body. The first is the weight of the body that acts vertically downwards. That is given by the mass multiplied by the acceleration due to gravity. And then by means of a rope or means of a string, this mass is held up, is supported in the vertical direction. And the force that is acting along the rope or along the string is called the tension. So T stands for the tension in the string. Recall that tension is a type of force measured in Newton as well. The resultant force becomes the difference, positive, that is the tension, minus the weight of the body, mg. So that's the expression for the resultant force that acts on this body. Now, the first case, suppose the resultant force acting on the body is 0. The resultant force on this body is equal to 0. That's the first case. That's, two things can happen here. Number one, it is either the body is at rest. The body is at rest. Now, when the body is at rest, it's a case of static equilibrium. It means that the two forces balance. The tension in the string is balanced by the weight of the body. In that case, we say that tension, the resultant force is 0, that is F equals 0, and the resultant force is T minus mg, that equals 0. Therefore, means that the tension in the string is balanced by the weight of the body. That's the first possibility. When a system of forces, two forces, act on the body of mass, as you can see there. Now, it's also possible that the body is in the state of uniform motion along the vertical direction. The body is in the case of uniform motion along the vertical direction, meaning that the body moves with a constant speed. The speed of the body is constant when the forces acting, the two forces, the tension and the weight are equal. The body is said to move with a constant velocity. And when the body moves with a constant velocity, its acceleration, whether upward or downward, is equal to 0. So when the resultant force is 0, it means the body's acceleration is 0. It means the body does not accelerate. And when you say the body is at the state of rest, it's just like a fan that is hanging up there at some point in the ceiling. Or the fancy light that people use in their houses is suspended from a point in the ceiling. It's not accelerating up or down. That object is said to be at rest. And then if it is moving at all, then it is moving with a constant speed. So, okay, I'm going to analyze this system under three different perspectives. Number one, I'm going to look at the case where the body moves upward. That is, the motion of the body is upward. Motion is upward. The body moves in this upward direction. Now, first of all, I can quickly redraw the diagram. Now, this is my body of mass M. And then by means of this string, it is held up, it's attached to a point up there in the ceiling probably, and then we have the weight of the body, mg. So when the motion is upward, that is, this is the direction of motion. I use this arrow to show the direction of motion. I can decide that the direction of motion should be given positive. The tension in the string acts in the same direction as the direction of motion. That is given positive. And the weight of the body, which acts downward, is given a negative direction. So when this body acts upward, you can see that this and this are in motion in the upward direction, and this is acting in the negative direction. Okay. Now, it's also possible that number one, the body is moving with a constant speed upward. When the body moves with a constant speed or constant velocity upward, it means that the two forces, the resultant force again is 0, and it means that the difference between the two forces, mg and t, is equal to 0, and t equals mg. That is when it moves upward with constant speed. What about the case where the body accelerates? Case 2, the body accelerates upward. The body accelerates the body accelerates upward, that is acceleration in A, in the upward direction. Okay, the body moves up with a constant acceleration A. Now, in this case, the motion of the body is upward, that is giving positive. Now, the tension acts upward, that is giving positive. Acceleration, I can use this symbol, I can use this diagram to represent acceleration, that is A. And then what happens? The weight of the body acts downward, that is mg. So the equation for the resultant force will be given by F equals tension, which is positive, minus mg equals mass times acceleration. Because from Newton's second law of motion, the resultant force F that acts equals the product of mass of the body and its acceleration. So it means that if I consider these two sides of the equation, I have tension minus mg equals ma. If the question requires you to calculate the tension in the string, it means that the tension in the rope or string, that is a pulling force. That's the force that is responsible for the motion of this body upward. That's the force that must be greater than or at least equal to the weight of the body and the accelerating force. This ma is called the accelerating force. Or maybe you have to find the acceleration of the body in the upward direction. From this same equation, I have my acceleration equals tension minus the weight of the body. That gives me my A equals T minus mg divided by the mass of the body. Now, this is the first case when the body moves upward with a constant acceleration. You can decide to use this equation if I ask to find the tension in the string, or this is the one for the acceleration of the body in the same upward direction. Now, it's still possible that this body, the B part of still the first one, here, let's say the body decelerates. It moves upward. It decelerates in the upward direction. Okay? Now, this time around, the motion of the body is still upward. Okay? The tension still acts in the upward direction. The weight of the body acts downward to give that negative. But the acceleration this time around is negative. Okay? So if positive is given to direction that is upward, then it means that negative direction will be given a negative sign. Okay, downward direction will be given a negative sign, meaning that the resultant force acting on that body of mass is positive for tension minus mg. From Newton's second law of motion, this equals mass times acceleration. And they recall that we said that downward direction is negative. That gives, when I'm asked to find the tension, given acceleration and the mass of the body, I have this is equal to minus ma or m times this, which gives me the tension in the string as minus ma plus mg. So this gives the tension in the string if the body moves upward with a constant deceleration. It decelerates as it goes upward. Okay, that's case 2. Now let's look at case 2 now. Okay, that's case 1. Let's look at case 2. The motion of the body is downward. Body moves downward. Okay, if it moves with a constant speed, it means that constant speed downwards, it means that the resultant force on the body, F, is 0. The acceleration of the body is 0 when the body moves a constant speed in the vertical direction. This body has no acceleration. The body moves a constant speed. Is F, the resultant force is 0, and the acceleration of the body is also 0. Okay, let's say the body moves, case 2, it moves with a constant acceleration downwards, constant acceleration A in the downward direction. What happens? Okay, let me redraw that. This is the body of mass. Okay, the tension is still acting in that direction. Okay, the weight of the body acting from the center of mass acts downwards. Okay, so since the motion is now downward, the motion of the body is downward, and the acceleration is in the same direction as the direction of motion, because as the body moves down, it moves with a constant acceleration. That is to say, the speed increases in the downward direction. When the body moves with an acceleration, that is, it moves with increasing speed as it moves in that particular direction. Okay, so in this case, we are going to write an expression, an equation for the resultant force that acts on this body. The resultant force, again, from Newton's second law of motion, is the product of the mass of the body and its acceleration, which is also giving downward direction a positive sign. So which means the motion will have positive sign, that the direction of motion is positive, acceleration is positive, and the weight of the body is positive. So this time I can decide to change the convention. I'm giving my downward direction a positive sign, which means any force that is acting in the upward direction will be given a negative sign. And therefore, I have my weight mg, which is positive, minus tension in the string, which is negative, equals mass times acceleration. My acceleration too will be positive, okay? So that if I'm asked to find the tension in the string, in this case, the tension in the string is going to be the difference. That is, if I bring this way, it will be mg minus ma. That gives the tension in the string when the body moves down with a constant acceleration. And if I'm asked to find that acceleration, of course, the acceleration is found from this same equation by taking the difference between this and that is the weight and the tension divided by the mass of the body. Okay, 3, how about the body decelerates? It moves downward with a constant deceleration. It moves downward with a constant deceleration. That is, so the acceleration is now of the body is still this. Okay, that's the direction of motion downward. The tension in the string is acting upward. The weight of the body is acting downward. Now, when I say deceleration in the direction of motion, it means that it is going to be in the opposite direction to the direction of motion. You know, when a body is moving in a particular direction, when the speed of the body increases, it means the acceleration of the body is the same as the direction of motion. When the motion is directed this way, this direction of motion, let me just explain this briefly, and the speed of the body is increasing, it means that the body's acceleration is the same as the direction of motion. Okay, when the direction of motion is the same as the direction of acceleration, it means the speed of the body increases. But when this is the motion direction and the body accelerates in this direction, of course, this one will end up reducing the speed of the body. So when the direction of acceleration is opposite to the direction of motion, this is the case of deceleration. Okay, so that if this is given positive, the acceleration will be given negative. So here the body is moving downwards. Okay, it's moving downwards and is decelerating. The deceleration now will act not in the downward direction, because if the acceleration was to act, or deceleration rather, was to act in the downward direction, then the body would rather be accelerating. So for the fact that the body decelerates, it means its acceleration will be opposite, whereas the motion is downwards. The acceleration will be upward. So I can give this motion direction positive, weight positive, tension acts upward negative, acceleration acts upward negative. So in this case, I want to write down the expression for the resultant force of this body for the third case. So the resultant force, let me get a new board because I'm going to move away from this page. I want to continue now by writing down the expression, the equation for the resultant force. So the resultant force F equals, because this one acts downward, that is mg positive minus the tension in the string is equal to m times minus a. Okay, I guess you are following me. So what do you think I should do now? We want to find the tension in the string. Suppose the question says calculate the tension in the string. The tension in the string becomes mg plus ma. So this is when the body moves with a deceleration in the downward direction, opposing, because this kind of a scenario can be very, very confusing if you are not very, very observant here. And if you don't pay particular attention here, it may just miss the concept here. So the tension in the string equals mg plus ma. That's the expression for the tension in the string. So we have analyzed the motion of the body in a vertical direction. The next video, I'll take some questions to see how we apply all these equations to solve them. Okay.